Thank everybody for taking the time to attend this presentation on integrating security into the Postman lifecycle. I'm happy to announce that the technology you're about to see here won the title of honorable mention as a part of the Postman hackathon. I will also say that the technology you're seeing here is available for a limited beta. So if you're interested in truly testing your APIs for security vulnerabilities, please visit the URL at the bottom of our slides, sign up, and you'll get access to everything that you see here today. There's a really interesting statistic that was put out by Postman in that there are approximately 46 million Postman collections created as of January 2021. That's a lot of collections. That's a lot more APIs. So that led me to ask myself, how often are those APIs being tested for security vulnerabilities? In my experience, the answer is they're not. But honestly, it is not the fault of the people who write the APIs. It is not the fault of the people who develop the collections to make sure that they're functionally correct. Honestly, it's the fault of the application security space and its inability to keep up with this community. If you've tried to test your APIs for security vulnerabilities, this has probably been your experience. You had to go acquire some tool, which requires security expertise. You had to go out and get documentation about your API, which hopefully was up to date and correct. Shadow APIs, right? And that, in addition to that documentation, you also had to make sure that you had sample data that you could provide those APIs. That's a lot of legwork. So what really happens in those situations? It's one of two things. Either you resort to manual penetration testing, which is fine, but doesn't scale. Or that's such a headache that you just choose not to do security testing at all, which is bad. Okay, so if we have to take a step back and say, what are the absolute must-haves? What are the requirements of security testing for a modern DevSecOps and API-centric world? The first requirement is it should not require us as users to be subject matter experts. I should not have to be an expert in application security to get security feedback and understand how to act on that data. The technologies in this space must support a DevSecOps world. But what does that mean? Right? That means performing and measuring the duration of tests in minutes, not hours, not days, not weeks, not months. The results must be highly accurate, and the entire process needs to be 100% automated. The technology must be able to integrate throughout the SDLC. So I could do on-demand testing on my laptop of my APIs. I can automate the testing of my APIs as a part of the build, whether it be my build pipeline or my release pipeline. And last, but certainly not least, and it's kind of funny, I have to say this, but I really do, it must actually support APIs. What do I mean by that? It means that the technology must automatically discover and consume APIs. It must automatically authenticate to the APIs, and it must actually have payloads and security tests designed specifically for APIs. I'm proud to say that we've baked these requirements into this brand new technology developed from the ground up specifically for DevSecOps and APIs called Intelligence-Directed DAST. We've integrated Intelligence-Directed DAST throughout the Postman platform so that you, as a member of the Postman community, can begin performing security tests of your APIs directly within your IDE. You can perform security tests of your APIs as an automated part of your build pipeline, your CI/CD process, thanks to our integration with Newman. So this demonstration will show you how you can begin performing security tests against your APIs. To that end, I want to introduce you to this public workspace and public collection called API Security Tester. This is what allows us to drive the security testing through Postman. Now, before I actually do security testing, I have to have some APIs to test. On the left-hand side, you can see a collection I've developed called Juice Shop Search. I've written a few tests here that allow me to make sure that this API at the path REST products search is functionally correct. The tests are pretty straightforward. So here's a test that says search for apple juice. So I search for apple juice. I make sure that I get the results back that I expect. Maybe I search for orange juice. Maybe I search for everything. At the end of the day, my test passed. So I know that this API is functionally correct. What I want to do now is I want to make sure that this API I'm working on locally on my laptop is also secure. And I want to do this before I even make a commit. To that end, I can use the API security tester collection within Postman to do this testing all locally on my laptop. To that end, the first thing I need to do is export the Juice Shop collection to a file. Now, the format of the file it really doesn't matter. As long as it's something that's supported by Postman, it's a Postman format, the API security tester collection and IDD under the hood will support it perfectly fine. Once that's exported, I go to the Submit Scan Job Request and click the Body tab. Here I actually have the ability to specify the collection representing the APIs that I want to test for security vulnerabilities. In addition, if I had a collection that was not self-contained, but instead dependent on variables in environment files, I could include those here as well. Now, let me go ahead and click Select Files, and I will select the Juice Shop Search Collection and click Save. With that said, I'm ready to begin security testing. Let me go ahead to the API Security Tester and run the collection using the collection runner. As you can see, the test is actively running. Now, I will highlight that all of this in its entirety is happening 100% on my laptop. So this vulnerability data, these scans, it's not being phoned home or sent out from your laptop. It's all 100% local. Now, by the time I finished that, you can see that the scan completed. We had 3 tests pass, and we see at the bottom that the scan completed, and then it's time to visualize the results. If I go to the Display Scan Results tab and click Send, you'll see at the bottom here a JSON response indicating the scan was successful. More importantly, if you click the Visualize tab, you can see what is effectively a near native view of the vulnerabilities directly within the Postman IDE. If I scroll down, you can see that there were 7 vulnerabilities discovered. At the very top is a critical vulnerability of the type SQL injection discovered at the path REST products search. If I drill down into this vulnerability, I can see its name, the fully qualified path to the API that contained the vulnerability. I can learn about SQL injection and why it is one of the most serious attacks, in that it allows hackers to extract a lot of sensitive data out of your database and perhaps even modify the data in that database. Furthermore, I can learn about how to go about fixing SQL injection in my APIs. Now, one of the most frustrating parts about using security technologies is chasing down false positives. What's great about our integration within the Postman lifecycle is that all of our vulnerabilities include evidence in the form of a screenshot. Here you can see a screenshot of what IDD saw when it submitted aggressive, non-production safe attack payloads to my API. So this serves as evidence that this vulnerability is indeed exploitable, which means for me as a developer, I know I am properly spending my time fixing a real vulnerability as opposed to wasting it with numerous false positives. If I close this out and scroll down even further, I'm presented with just-in-time micro lessons. These are 2 to 3 minute bite-sized videos that show me very quickly how to fix vulnerabilities directly within my application, specifically my APIs. So in 2 to 3 minutes, I learn what I have to do to fix these vulnerabilities. I'm learning application security when I need it most. Compare that to spending hours or days in some other fictitious application or environment. Right here, we're actually learning how to fix our own vulnerabilities in our own API. Armed with all of this information, I have everything I need to go and fix the API, fix the vulnerability, retest it locally, verify the vulnerability is fixed, and then commit my code. Now, with that said, that will conclude the first part of this demonstration. The second part of the demonstration is how do we go about integrating the security testing as a part of our CI/CD pipeline? Now, to that end, I'm going to show you a build pipeline configured in the Jenkins build server, but I will highlight that nothing in here is specific to Jenkins. If we were to use Azure or any other type of CI/CD technology, Travis CI, Circle CI, the process would be the same. I have 3 phases here, and the first phase I'll highlight is API tests. This is where all of the Postman collections are executed through Newman. The second phase I'll highlight is security tests. The security test phase takes the output of the Newman run as input for security testing. And from there, it'll test all the APIs for security vulnerabilities. Looking at this build here, I actually had a build recently that failed. Functional tests passed with the big green box, but we got a red box indicating the security test marked the build as a failure. If we take a look at the build output here, we can actually see that IDD marked the build as a failure because it found a critical security vulnerability. If I scroll up in the build output here, we can see a SQL injection vulnerability was in fact discovered against the REST product search API. So within seconds, we identified security vulnerabilities as a part of our build pipeline. Now, with that said, that'll conclude the demonstration portion of this talk. And I would like to emphasize that nowhere in this process did I have to be an application security expert. Intelligence-directed DAST allows us to achieve the modern requirements of API security testing. I did not have to be an expert to do anything I just did here. It is IDD supports a DevSecOps world. We had results in seconds that were accurate in a fully automated way. IDD integrates into the entire SDLC on your laptop in a build pipeline and a release pipeline. And IDD is API native security testing out of the box. It automatically discovered APIs. It automatically authenticated against those APIs and dynamically constructed attack payloads specific for the APIs that it was testing. IDD was able to do all of this without leaving the Postman platform that you know and love today. So with that said, you can clearly see why this project won the title of honorable mention as a part of the Postman Hackathon. If you like what you saw here today and are interested in truly automating the security testing of your APIs, please go to the URL that you see on the screen here, register, and we will make this available to you so you can start your security testing today. Thank you, everybody, for taking the time to attend this lightning talk. And I appreciate it and look forward to speaking with you soon.
Eric, thank you so much. Really good. I know some people were talking about the text was a little difficult to read. It's really, I think, a constraint of the platform. I think your text will be, you can zoom in, it'll be more visible when folks, if they want to go back and watch the recording. So really good stuff. If anybody has any questions, you can go ahead and put them in the chat. We have another about 1 minute before the next session starts. Let me check Slido in the meantime. Oh, just another reminder, in Slido, there's a survey just for Eric's session here, if you wouldn't mind filling that out before moving on. I don't see any questions there. You're getting lots of claps down below. So, oh, Kristen's asking a question. Can you describe the different kinds of security test runs?
Sure. Yeah, so there's a number of security tests that are running, including SQL injection, cross-site scripting, cross-site request forgery. What we did in order to select the security tests that were run is we initially based off the OWASP Top 10, the Open Web Application Security's Top 10 project. So out of the box, you're getting fast and automated security testing against the vulnerabilities that are most critical that you, from a developer's perspective, that you need to defend against.
Yep, perfect. Thank you. All right, that's time. Any other questions? You can go find Eric. I'm sure he's going to be hanging out at other sessions. So, all right, thank you again, and we'll see everybody at the next session.
Thank you.